Hello, Stephanie. I just
Hi.
have a couple questions with my homework. Hello. And
Sure.
I was wondering if you could help me out. I guess I'll have to read it off to you because I can't show you them. But if I see this first one, I'll be good to go. So it's a
Okay, cool.
fraction,
Okay.
and it says simplify the following expression completely. Okay, whatever that means. Well, the top is 8x minus 72.
8x minus 72.
hmm And then the bottom is x squared minus 16x plus 63.
Okay,
Okay, so
cool.
I just don't know how to get started
Yeah,
there.
no worries. If you can, do you know what section this is and what number? So I can
Yes,
have it
this
up
is
here.
section 4.1, and it's the first question, question number one.
Okay, can you see everything that I wrote on the board?
I can.
It should be the section number, the problem, and then the fraction that you told me.
So,
Awesome.
yes, I can
So
see it.
yeah, great. So what this question wants us to do is simplify fractions. When we're simplifying, what they want us to do is if it's just one fraction like this, we want to factor the top and factor the bottom. Factor wherever you can possible. So in the
Okay.
first, in the top here, 8x minus 72, do you recognize anything you can factor out that they have in common?
Let's see. Oh,
Should,
could you slide over
yeah,
just a little bit? Yeah, that, okay,
like
now I
that?
can see it. Yeah,
Okay, no
now I can
worries.
see it.
Thank you
So
for
let's see
telling
here.
me.
Oh, no problem. Thank you for moving. Let's see here.
Should
Well,
be
I can't.
possibly an 8, maybe?
Well, I can I do like the two parentheses or
This one is only going to be just one group because 8x minus 72, they only have one common number, which is 8, that they're both divisible by. It does
oh,
go
I
into
see.
two groups. For instance, the bottom one will go into two groups. The only time a binomial, two terms, will factor out into two groups is if it's a difference of squares. But a difference of squares is when you have the first term and the second term a square, which in this case we don't, and if there's a difference between them, so they're subtracting. But in this case, we don't have that.
So
So
is the way
it's
that I know the
just,
first one's not squared is because that x doesn't have a little two above it?
yeah, that as well.
Okay. Okay.
This second one, though, will come into two groups. It does have a 2 here.
Okay.
So, and it's a trinomial, and most trinomials will come out into two groups, just
Okay.
like you said earlier. So, and then when it does come into two groups, the very first terms will be x and x. When there's no number in the front, like here, there's no number in the front. Or if there is, you can think of it as a 1.
Okay.
Um, and then that will come out into x, and then now we have to do is determine what our two numbers here in the last two for the groups will be and their signs.
Okay. So
So
how do we do that?
now to do this, not too bad. We're gonna be when your number up here is a 1, you want to find two factors that multiply. I'm gonna write an m for multiply to 63 and add to negative 16. So if I'm looking for factors that multiply to 63, what I like to do is just write it out on the side here. So 63 and then two numbers. So for instance, if I just started writing factors, 1 times 63 will give me 63. And then you could just start dividing down the line. If you're not sure, you can even use a calculator. So I could
Okay.
type in like 63 divided by 2, and it gives me a decimal. You don't want to use decimals. You want to try to only focus on having whole numbers. So
Okay.
63 divided by 3, 21. So I would write 3 and 21. And then just keep going down the line until what we're aiming for is finding two factors that you can play with the signs with, have an addition or subtraction, and then get to negative 16. So for
Okay.
instance, if I had maybe positive 3 and negative 21, and if I do that on my calculator, or if you could do that by your head, it'll give me negative 18. So we're close, but we're not quite there yet. But we're looking for these factors of 63 that also add up to negative 16. Add or subtract.
Okay.
Make sense? So
Makes sense so far.
yeah, so if we just keep playing around, I mean, divided by 4, it gives me a decimal. 63 divided by 5 gives me a decimal. Divided by 6, and so on and so forth, until we eventually will get divided by 7, which will give us 7 and 9. So the reason I write down this chart on the side is just to make sure that you're not repeating the same numbers. and it's kind of a good way to visualize it. So just as a tip, if you like this, 7 and 9 though, if we have assigned a positive 7 and a negative 9, we'll get negative 16, excuse me. Does that make sense?
But that's if we have a positive 7 and a negative 9?
Yeah, positive 7 and negative 9. Oh, actually, good point. I forgot this had to be positive 63. So they do need to multiply to positive 63. Is this,
Okay.
first of all, this is how you told me the question was, right?
Yes.
Negative 16, positive 63. Okay, yeah. So thank you for catching that, actually. Yeah, they do actually need to be either both negative or both positive to give us a positive 63, and then add up to negative 16. Thank you.
Okay. No
So
problem.
this one wouldn't work. But had it been a negative 63, we would have used these two. So
Okay.
are you understanding the process of how to do this at least?
That is making sense to me as far as finding the numbers. Now,
Yep.
one
Perfect.
thing I'm confused on is
hmm
how are we going to add two numbers and get a negative 16?
We can add two numbers if one of them is a negative. That's what I meant
Okay.
by adding them.
But what if they're
Sorry if
both
that
negative?
was if they're both negative, then two negatives added together is a bigger negative.
Oh, okay.
Does that make sense? So if
So,
I had like negative 2 plus negative 3 will give me negative 5.
okay, just more negative. Okay.
Yeah. Sorry, that's what I meant by adding. You
I
can
see.
call it also subtraction, because adding a negative you can simplify it as a subtraction. But either way, they are similar to the same. But
Okay.
if that makes sense. But thank you.
That
I mean,
does.
like, ask me wherever you need me to clarify, and I'll do my best. But
Okay.
seeing as how these two numbers won't work because they would need to be. Oh, actually, they do if it was negative 7.
Okay.
Oh
So
no, I
you
have
just,
positive 7. Yeah, I'm so sorry about that.
okay. Okay. No
But no,
problem.
you're wonderful. So negative 7 and negative 9. Do you now see
Okay.
where we're going with this?
Yeah, because if I add those,
Yes.
that'd be 16, and you just told me
hmm
that when I add two negatives, it just becomes more negative. So, okay.
Exactly. Right. Two
So,
smaller negatives added together just gives me a bigger negative number.
okay.
Cool.
So it's just going to be those two numbers, the negative 7 and the negative 9, right?
Exactly. So, and it doesn't matter
Okay.
in which order you put it. I could have this be negative 7 and this negative 9, or vice versa. Multiplication is cumulative, so you switch it if you'd like. Does
Okay.
that make sense? Yeah.
Makes
Cool.
sense. That's like, is
Awesome.
that like 2 times 3 and 3 times 2 are the same thing? Is that
Yes.
the same
Yes.
reason? Okay.
Exactly the same thing. Right. They're both
Okay.
equal to 6. Okay.
I see.
And now we're almost done. This is in a way the hardest part is getting the factors correct and the factoring, because now if you notice we have the same group repeated, x minus 9 at the top and x minus 9 at the bottom.
Okay, and it has to be that whole thing inside the parentheses that goes out?
Yep, exactly. The exact same group. And then
Okay.
and if you see them repeated at the top and bottom, you can just cross those out.
Okay. And so
Okay.
the final answer is just going to be the 8 times 1 over x minus 7 times 1?
Yep, 8 times 1, exactly, yeah. Because what happens is when you cross these out, x minus 9 and x minus 9, you're actually dividing it, so you can replace it with a 1.
Okay.
So it is 8 times 1 over x minus 7 times 1.
Okay.
And then this 1 you can pretty much ignore because it's anything multiplied by 1 is just the number itself.
The same thing.
So,
Okay.
right, exactly. So on iMath AS, you probably just want to put 8 over x minus 7. Just
I
like
see.
that.
Um, yeah, question number 5, I actually,
Number
it's
5,
asking me,
the same section, 4.1? Or,
it's the same section, 4.1, and it's
okay,
question number 5.
perfect.
Okay. And it's asking for the domain of the function. So I know that a function is just basically it's y, but I don't know what this
Not quite
domain.
close. Domain would be your x values.
Oh, but the function, the f of x bit, that is y, right?
Oh, yes, that
Okay,
is
okay.
y.
So I do have that right. But domain, I didn't know what that was. But you said it's my x values. What do you mean by
Right.
that?
The set of x values that the graph or your function, if you were to graph your function, would cover. So what ranges in that function or equation that you have is all coverable by your x. So, and we can figure
Okay.
that out mathematically without needing a graph also, if you just have your equation.
Okay.
Did
So yeah, I
they, did
do.
they give you an equation or a graph? to look
They
at?
did. They gave me an equation,
Okay.
and it says that f of x is equal to, it's a fraction, and
Mm-hmm.
it's equal to 37 on top in the numerator, and it's divided by 9x minus 20.
Okay.
Hmm?
Perfect. So the first thing we're going to do is when we're looking at domain, because it's looking at your x values, we want to pay close attention to those x values. And it's really important when it's in your denominator because that's in a way the problem. We can never divide by 0. So because we can never divide by 0, we need to make sure that this denominator is foolproof for not being 0. So what we're going to do is set this entire denominator, 9x minus 20, not equal to 0. This not equal sign, you can treat it as just like an equal sign when you're solving it. But the reason I would just tell students to go ahead and put this not equal sign is just to don't forget it. Because when
Okay.
we're solving for x, we just want to make sure it's not equal to the value this is going to come out. Because when we plug it back in, that's going to, it's just making sure that this denominator won't be equal to 0.
The whole denominator.
The whole denominator, right. What
Okay,
you want,
I see.
yeah, right. And it won't happen really in this class, but I know in college algebra, you're going to have to factor the top and the bottom. Just make sure that the top and bottom are factored out as much as you can. You can get into practice and just by looking at the function. Is the top factored out? Is the bottom factored out as much as possible? And if it is, then that the first step would be to factor. And then do this. Take your
Okay.
denominator and set it not equal to 0.
Okay.
hmm So
That
for
makes sense.
solving this, yeah, so are you okay so far?
So far, so good.
Okay, great. So when I'm solving this, what I want to do first is maybe add 20. So if I
Oh,
add
okay,
20 to
because it's
both
minus
sides,
20.
yep, because it's minus 20. So just add 20 to both sides. And so now it would be 9x is not equal to positive 20. And
Okay.
then my next step would just be to divide by 9 to both sides.
Okay.
So it's now x is not equal to 20 over 9. And if I were to plug that in up here, that would give me a 0. That's why it's not equal to this value.
Okay.
Okay?
Okay. So, and I noticed they say it's the domain is all real numbers x except for x, where x equals.
Equals, and
Okay.
that would be
Oh,
this
oh,
value.
this
Yeah.
number.
The way,
Ah,
and the way they worded that is because you can plug in any other number for x. You can plug in a 1. You can plug in -3. You can plug in decimals, 0.0555. It can be any other number except this value.
I see. Okay.
hmm Because when you plug in this value, the denominator will be 0. So
Okay.
that's why it's worded that way in your iMath AS.
I see.
hmm
Okay. So let me go ahead and type that in and make sure.
Yeah.
Da, da, da. Okay, yeah. All right. And so they're
Awesome.
all going to be
Perfect.
that way. Just take the denominator, set it equal to 0, and
Yes.
solve.
Yes,
Okay.
exactly. And that's any
Okay.
and that's for questions regarding the domain.
That makes sense. Okay.
Okay, cool. So are you okay with me erasing this?
Yeah, that's fine. I
Right.
took it down.
Awesome.
Thank you very much.
Perfect. Thank you.
So I still had one more question, if I can bother
Okay.
you with that right quick.
Of course,
Um,
please.
so it's question number 7 from the same section, 4.1,
Okay.
and they give me what they're calling a rational function, and they say that
Okay.
it's f of x is equal to 2x plus 1 over x minus 5. And then there's a few steps to this one. If you can show me
hmm
the first one, I think I should be at least a little better with it. So let's see. It says find f, and then they've got the parentheses, and instead of putting an x there, they put 0. How would I read that?
Okay, so that's f of 0. Basically, all they want you to do is replace because and you mentioned this yourself. You said instead of the x, they have a 0. That's exactly what they want you to do. They want you to replace, if they give you this as the general function, f of x is 2x plus 1 over x minus 5, then f of 0 will be 2 times 0 because you're now replacing all of the x's with zeros. Do you see how that's coming out?
Okay.
And then this would be a 0 minus 5. and then
Okay.
simplify. That's all they want you to do.
So in that case, that would be
Hmm.
2 times 0. That's just 0 plus 1. That's
Yep.
okay. So that's 1.
Yep.
Then the bottom, what's 0 minus 5?
0 minus 5, anything added or subtracted by 0 is just the other number. So in a way, this is like 0 minus 5 is just negative 5.
Okay.
You
And
keep
with
the sign to the number. Nothing happens with that. 0 won't change that. Won't change
okay.
it into a positive or anything. So it just stays as negative 5.
Okay. And is that how I would actually write it? Is just 1 divided by negative 5 and that would be it? Or
Yeah, pretty much. You can choose to write this negative if you wanted to on the outside of the fraction, um,
Mhm.
or really anywhere else. You can have it on the outside of the fraction or at the top assigned to the negative 1, and then this would be a positive 5. Because either way, negative 1 over positive 5 is still negative 1 over 5. You can move this, the negative sign on the outside of the fraction. Similarly, positive 1 over negative 5, you can move this outside of the fraction just like that.
Okay.
It's the same thing. It's however you choose. It's personal preference, really.
Okay. So that makes sense. They've got some other ones here.
Okay.
If you don't mind, could we actually work those out together? Like I'll tell you what I'm doing and you tell me if I make a mistake anywhere?
Yeah. Does this make sense? Are you okay with me erasing this before we continue?
Let me look at that, copy that down right quick.
Okay.
So, yeah, that makes sense to me. Yeah, yeah,
Okay.
and I got it, so I can look at it
Okay.
later.
Perfect. Perfect. And is this from your next question is from the same section?
It's this same question. This question has multiple parts.
Oh, okay, okay.
So,
So I
so
won't have
the
to. All right, I'm just making sure, like, if I should have changed my section number or the problem
oh, okay,
number. But if it
gotcha.
remains the same, then I'll just erase the work we just did. Perfect.
Okay. So yeah, so it's still using that same function. Um,
Hmm? Oh, whoops. I erased it, but I'll make sure to write it again. It was
okay.
f of x equals 2x plus 1
Mm-hmm.
over x minus 5, right?
Yeah.
Awesome.
And so this next one says f parentheses negative. So you said f of -1.
Mm-hmm.
And so everywhere I see an x, I'm just going to put that number,
Yes,
right?
exactly.
Okay, so that's 2 times 1. Oh no,
Negative 1, right?
-1. Okay, I see. So 2 times -1 plus 1
Mm-hmm.
divided by, so that's going to be a -1 minus 5.
Mm-hmm.
Okay, so 2 times -1, that's -2, right?
Yep,
Okay, so -2 plus 1. -1 minus 5, that's going to be -4?
that's going to be negative 6.
Negative 6. Oh,
Yeah.
okay.
Just
Oh,
make sure
because
that they're
more
both
negative.
negatives, right. If it was a positive 1, then it would be negative 4.
Ah, okay,
But
so it'll be negative
when they're
6.
both negatives, you want to add the values together. 1 plus 5 is 6, and two negatives added together is a bigger negative, so it just stays negative, negative 6.
Okay, so that, okay. And then on top, I've got -2 plus 1.
Yep.
So that's, oh, okay, okay. So now the signs are different. So
Mm-hmm.
if I owe $2 and I pay $1, so that's -1?
Perfect.
Okay, so I have -1
Mm-hmm.
over -6.
Yes.
Okay, and is that how, that's it? That's how I would write my answer?
Really close. You can simplify this one more step. When you have a negative divided by a negative, that becomes positive. So you can
Okay.
simplify this a little bit further and call this 1 over 6.
Oh, okay.
But other than
Huh.
that, you did a beautiful job.
Okay, cool. All right, so let's see. So the next one says f of, hmm? Okay, so this one's kind of weird. It doesn't say f of 7. It says f of x equals 7. So you say when f of x equals 7, comma, x equals, and then there's a box. So I'm not sure I understand what they're asking for on this one.
So they want you to evaluate when x is equal to 7 for f of x.
I don't, I'm not sure because it doesn't say f of 7. It actually says f of x equals 7.
F of x equals 7. So like this, f of x equals 7, like that.
Yes, and then they have comma x equals blank.
Okay, perfect. Yeah. So what they want you to do is work in a way backwards almost. Instead of plugging in the 7 for x, your output will be 7. So are you okay with me erasing for when we solved for f of negative 1?
Yeah, I'm fine with that. I got that written down.
Okay, so I'll go ahead and erase this and like show you how that setup is going to work with f of x equal to 7. It's not
Okay.
that bad. But yeah, instead of them giving you a value for x to plug in, they want you to find that value. And the way they do that is that they tell you that your output, your product, or in this case division, will be 7. Oops. Well,
Okay.
let's go ahead and erase this too. So that all that means is instead of, because it says f of x is equal to 7, they're telling you that this will be 7. So 7, and then it's still equal to, this stays the same, 2x plus 1 over x minus 5.
Huh. So how can I solve that? Because over there where I plugged in the number, there's no variables or anything for me to work with.
Right, right. But we do have one variable. See, x
On the other side, yeah.
on the other side, right. So whenever we have one variable, you just want to use algebra, multiply, add, divide to try to isolate x. And when we have a division, fractions, usually the best way is to try to get rid of the fractions if you can. So you see how this whole side is dividing by x minus 5?
Hmm.
What we can do is multiply both sides by x minus 5.
So, okay, so in general, are we always just going to multiply by the denominator, or?
That's usually, yeah, a good start. If you have more than one denominator, you want to try finding the least common denominator and multiplying that to the whole equation. And that will get rid of your fractions for you.
So like if it was 2x plus 1 over x minus 5
Mm-hmm.
plus a whole separate fraction and so on, like that.
Yes. Yeah.
Ah, okay.
Okay.
I see.
So, and then what it'll do here is it'll just cancel out with these denominators. But you just want to make sure you do it to both sides because in math, we want to make sure everything is equal and fair. So whatever I do to
Okay.
one side, I must do to the other side.
Okay.
Okay. And so now if you wanted to, you can even distribute this. So it'll be 7
7,
times x.
which is
Mm-hmm.
just 7x. Okay.
Right?
7 times 5, that's 35.
Negative 35 because this is a minus, but yeah.
Ah, okay. Gotcha.
Mm-hmm.
Okay.
And then on this side, because the x minus 5 is canceled out, all I have left is 2x plus 1.
X plus 1. Okay. So,
So now what you want to do is, now that we have it to this step, 7x minus 35 equals 2x plus 1, you can combine like terms and try to solve for x. So basically, move all of your other numbers and variables around to where you have the x's on one side and then everything else on the other side, all the other numbers on the other side.
okay. So, could I subtract the 7 from both sides?
Yeah, you could do that. You can
Okay.
subtract 7 from both sides. Minus 7x minus 7x. And if you do that, these 7x's will cancel out, so then I'll have negative 35
Okay.
equals, and then 2 minus 7 would be negative 5x
Negative 5. Okay.
plus
Okay.
1.
Um, then would I
Mm-hmm.
would I add the 35 to both sides or?
You can, but you see how you're really close to just having that negative 5x isolated? You could even just move over the negative 1, this 1, subtract 1 to both sides, and then
Oh,
have
okay.
just the 5x by itself. Because we want to have the x by itself. But you see how
So
there's
what?
still this 1 left over?
Okay. So once I have everything with an x, or once I have
Mm-hmm.
just one x, I want to move all the other numbers.
Yes, yes.
Ah, okay.
So minus 1. And then negative 35 minus 1 is just negative 36 equals negative 5x.
So, oh, okay. So because this is negative 5 times x, I would just divide both sides by the negative 5.
Perfect. Yep. So
Oh, okay,
divide
okay.
both sides by negative 5.
Oh, I actually can't see what you're writing because
Writing?
it's going below
Okay.
the board.
Just
So,
making sure. I was
okay.
actually about to ask you that too. So what I'm actually going to do is, can you see me how I drew that arrow?
Yeah, that looks good.
Okay, perfect. So I'll just continue doing it over here. And then
Okay.
this is going to be, you said divide both sides by -5, so we'll have -36 over -5 equals to x.
Okay.
Oop.
And then, oh, when we did the f of -1, you told me when I have a negative over a negative,
Mhm.
that's positive, right?
Yep. So
Okay.
positive 36 over 5 is equal to x.
Okay. And we can't reduce that because that's just
Right.
6 times 6.
If it was 35 over 5, you would
Okay.
be able to reduce, but not in this case, right? So this will be your final answer for x.
Okay.
Cool. Not too bad, I
Cool.
hope.
No, just okay. So f of x, like I mentioned, is just like y, and so if they say that, they're just saying this
Exactly.
is y, and then you
Mhm.
figure out what x is.
Yep,
Okay.
f of x is y, so yeah, and you caught that off at the very beginning. So I was like, okay, you got this. But yeah,
Okay.
yeah, definitely. So hopefully that made sense and that answered your questions. If you have any more, feel free to ask me.
No, that made sense.
Okay.
Thank you very much.
Thank you. If you have any more questions, don't forget you can reach me virtually. So this was a
Okay.
great session. Thank you.
Cool. Thank you very much.
Thank you for coming.
All right. Bye bye.
Bye.